Hello, my name is Khalidi Masada, and this presentation is a brief summary of the Deyo Charleson Index project that we have studied the past 4 weeks in HAP 464 with Professor Baji. So why is the Deyo Charleson Index used? It is a score to predict risk of death for patients with specific comorbid conditions within their first year of hospitalization, and those conditions are mostly found in hospital data. How did it start? The Charleson Comorbidity Index was named after Mary Charleson, who originally developed it in 1987 with 19 categories. Throughout the years, the use of diagnosis-based prognosis indices has seen some evolutions. Following Charleson's work, Richard Deyo added some modification in 1992 with 17 categories. In 1993, Patrick Romano adapted the Charleson Index to ICD-9-CM diagnosis and procedure codes and CPT-4 codes so that the index could be calculated using administrative data. In 2002, Hawthorne and allies updated ICD-9 to ICD-10 coding. In 2003, Hawthorne and allies and Schneeweiss and allies had modified the original weight developed for use with the index. In 2005, Quan and allies updated ICD-9-CM to ICD-10. So how are these variants of the Charleson Index used in the clinical field? The Charleson Index, which predicts the risk of death for hospitalized patients, has been used to predict mortality rate in COVID-19 patients with the help of artificial intelligence. The Deyo Charleson Index predicts long-term survival rate and is used on cancer patients in the last stage admitted in ICU. The Romano-Charleson Index, which lists the specific ICD diagnosis codes, is used by CDC to conduct surveillance. In the following slides, I'll go over data presentation starting with data cleaning. I merge the tables into one table, then change the data type. I removed visits after death, vampires, or patients whose date of birth are impossible, including negative. Ghost or patient with no visits. After completing the following steps, the patient record I ended up with is 17,431,402 patients. After cleaning the data, I need to score it by using the diagnosis from Deyo Charleson Index, and I assign a score for all categories. I was able to score with the correct coding. In the last step, I have to find the accuracy of the index assigned to the patient. The graph below shows the area under the curve of 0.5685, and it's pretty low. The area between the blue line and the gray dashed line is small, and it means lower accuracy. The closer the area is to 1, the more accurate is the index. In this case, it's not accurate. And some possible ways to improve the accuracy of the index is by adding more data. The more data we have, the more accurate the index. And by having an updated list of diagnoses, consistently editing, removing, adding diagnoses, neatly listing the codes to avoid missing codes. And this brings us to the end of my presentation. Here is the list of my references. Thank you for listening.